again, welcome everyone to today's webinar, which is called Kubernetes is Secured by Default, which to some extent is true. It's improved a lot in past years, but there are still some things that you can improve on your own, and security is always a lengthy process. So when we talk about security, especially with Kubernetes, it's a complex topic and cannot be covered in 1 hour, but I will try my best, and I will try to pinpoint all the things that you should focus on, and we'll try to at least mention them and lead you to some further actions that you can take on your own. Feel free to ask any questions that you might have. I will try to answer them in the end of the presentation. Okay. So before we start, let me shortly introduce myself. I'm working in Runecast as a system engineer for like 3 years. I'm focusing on Kubernetes and automation, and also on content. I was in IT, I'm in IT for more than 20 years, and was working mostly on the ops side. Previously, before I joined Runecast, I was working in major Europe's retailer. Greetings to my colleagues at Notino, and I was working there as infrastructure architect in different fields of interest like VMware, networking, security, but also Kubernetes. So we have the introduction down, so we can finally start with the presentation or with the webinar. When I think of security, for me, it's always about eliminating the risks, or if not possible, eliminate them, then minimize them. And with systems getting more complex, it might seem overwhelming. So it's good to divide the system in layers, and that's what exactly 4C is about. That's a concept building on defense in depth, which can be found in Kubernetes documentation, and it basically says that you can divide the stack into layers, and you can build up the security by the layers. So you start on the lowest and build it up to the top to the code. This applies to any stack, but for Kubernetes, this can be formed into 4 layers. And when we look at the picture, that is directly from the documentation, the first layer is the data center or cloud or corporate network. And that is basically something where the Kubernetes is cluster running. So it's compute, it's networks, it's something that you connect to, and where basically it's all happening. This is nothing new. Every time the workload needs to run somewhere, so no changes from before Kubernetes. You need to secure it like you used to. So you need to leverage least privilege principle. You need to give only those permissions that are needed for the work that people or services are doing, and you should also follow the best practices that either the cloud providers or the vendors of the data center will give you. For example, VMware. So there are some security best practices that you should follow, given by the vendor or the provider. Also, you should use encryption. That means not only when connecting to the data center, but also when storing the data in the data center. We will get to that later. Moving on the layer above, which is cluster, that's basically the actual cluster, the nodes, the control plane, and we will talk about this in detail today. The same applies to container. This is not specific to Kubernetes, but Kubernetes is containerized or orchestration of containerized workload. So containers are present here, and there are some specifics that can be set in Kubernetes. So that's also something we will focus on today. And in the last layer, there is a code. So something that is basically doing the job, that is running the instructions or doing whatever you need. So that might be your application that your company is building, or it might be third-party code that you are running in the container. Here, if it's your code, you can do static code analysis. You can do penetration testing. Also, there were multiple breaches in the how to say, in the line of the packages. I can't find the word. Sorry. So there are dependencies your project or the third-party project might rely on, and there were breaches that stepped into the supply chain. That was the wording. So you might check your dependencies. There is a trend of software bill of materials that might help you to do that, and to know that what the actual application is using, and have more control on the code. So that's just overview of the concept. And now let's look on these two layers that are cluster and container. So when we are talking about cluster, this can be cluster that is managed, that is running in the cloud and in control of the cloud provider. But you can also have clusters that are deployed on-premise, like KubeADM managed clusters, which the control plane is in your hands and you have full control of it. So the recommendations or the things you can resolve there might differ based on these two approaches. But most of the things we will be talking about are common. So here are some points I wanted to point out. First, there is cluster API. That is the heart of the cluster. That is something that is controlling what is happening in the cluster. And it is also something that should be secured in the first place. So what I've seen in the past is that, for example, cloud providers are really making it really easy for you to deploy the cluster and having access to it, but also the cluster is exposed to internet, and that is not something you should do in production, because it can be easily reachable by attackers, and slight misconfiguration might cause some harm. So I would recommend not having the cluster accessed from internet, and having it in private networks. Or you can leverage the zero trust approach and have some way of connecting and authenticating users directly to the API. So nowadays the possibilities are different. So just to know that the cluster API is really important and shouldn't be open to internet. And that doesn't mean only from internet, but also from inside. The API should be accessible only to those users and services that need it. And this applies to inside of the cluster as well. So if the pods that are running there don't need to access the API, they shouldn't be able to do encryption. We already mentioned it on the lower layer, but that's why I mentioned it. Kubernetes API has backend of etcd database where the data are stored, and access to this database should be secured. So again, the the traffic should be secured, so encryption and transit. Also, the database stored on the disk should be encrypted. There is possibility to encrypt the database directly. Also, you have the option to encrypt the storage. Authentication. Recently we had some news that spoke about known attacks on clusters that are exposed to internet. So this is exactly the example why you shouldn't do that. So the clusters were exposed, and the authentication was set as anonymous, and the attacker was able to read some secrets that he used he used to leverage his permissions and create new accounts, create new roles, and establish presence in the cluster, and then use it to do malicious stuff. So you should always authenticate. For services, this might be different, but let's talk about the users of the cluster. The best would be probably OIDC tokens because they are short-term. They can easily be revoked, or they are revoked when they expire. And there are other options which you can use to authenticate to the cluster, but this one is probably the most efficient for the users. There is also certificates which can be used, but the Kubernetes CA that is by default used doesn't have any revocation mechanisms. So when the certificate leaks, you don't have a way how to get rid of the authentication. So I would encourage you to not do that. You can also implement your own certificate authority and use it for Kubernetes, but that is a complex topic and not easy to set up. You can also use service accounts. Again, this shouldn't be used for users because the tokens are more permanent. So IDC is the way to go for users, probably the most easy. And you can link it to Active Directory. You can link it to other OIDC providers, even Google Authentication. So that is helpful. Another point, updates. There is the saying, if it does work, don't touch it. But really, I don't think we need to stick to this ancient rule. We all know that there are vulnerabilities in software. Each software has vulnerabilities. There are issues that need to be fixed. So with each update, you will get this, and you will get more vulnerable, and you will lower the risk. Of course, updating the cluster might be a risky operation, but that's something that you should prevent by having additional infrastructure, having other cluster where you will test all the updates and will make sure that the update on the production will be seamless. Okay, auditing, that is something that is not enabled by default in Kubernetes, and you should absolutely do that, because without that, you don't have any evidence what was happening in the cluster, who did what change. And that's not because you want to blame someone, but because you want to know what account was used to do some stuff that might be, let's say, dangerous, and you want to know if the account was doing it like intentionally. So if it's not stolen, for example. So that's why you should enable auditing. CNI, that's shortening for container network interface, and that's basically the first thing you deploy to the cluster. It's enabling the network communication between the cluster nodes, I mean the pods, and basically the stuff that is running in the cluster. And it allows you it might allow you to use network policies which will limit the communication. So by default, the communication is not limited at all. And you should use CNI that will support these network policies, and you can set these network policies to limit the communication. I'm not sure about the current state, but I remember, for example, WeaveNet or Calico support network policies in both ways. Let's discuss why both ways. So you want to secure the traffic that is coming to the cluster, that is coming to the pods. So for example, you can have network policy that will limit the traffic flowing to the database, and it can be limited to specific service that is running in the same or in other namespaces. So that way, the database will be accessible only by those workloads that needs it. In Kubernetes, it's similar like in firewall policies. You can set it with network rules, with IP addresses, but you can also use Kubernetes labels, so that makes it easy to to create the rules that will support the dynamic environment. Why limit egress access? You want also to control what the pods are able to do. So you don't want the pods to have unlimited access to outside network. You don't want to make it easier for the attacker, and also not only to outside network, but also to the API, as I mentioned. So if the pod doesn't need to communicate with the API, it shouldn't be able to. So you should limit it on the network level. Another point is kubelet, that is a node agent that is running on each of the nodes that are in the Kubernetes cluster. And basically, that's an agent that is doing the heavy lifting on the nodes. It's communicating with the API. On the other side, it's communicating with the container runtime and is doing the job that it should. And it has potentially some sensitive information. It has also high rights, so can do anything on the node. So it should be controlled. Luckily nowadays it's set up securely by default. It is secured by certificate. It's not anonymous like it was before. There is still something that can be done to improve the security. You can use server certificate rotation on the kubelet side. So that's basically overall of the things you can do in the cluster. I have skipped one point, and that is authorization, and that's something I would like to discuss in more detail. So if you authenticate, you will connect to the cluster. Then there comes authorization that will say what you can exactly do in the cluster. There are several modes that can be used in Kubernetes. Obviously, you shouldn't use always allow, because then anyone who is able to authenticate can do anything in the cluster. But nowadays, probably the most used is RBAC, which stands for role-based access control, and this will allow granularly to assign permissions to subjects that are connecting to the cluster. So whether it's developer, administrator, or service, you can control what permissions he will have in the cluster. So there are roles and bindings which are related to a namespace. Then there are also cluster roles and cluster role bindings that are on the level of the cluster and will give permissions to the whole cluster. So we can use these to limit the permissions the entity which is connecting to the cluster has. Again, you should stick to the least privilege principle. So you shouldn't give the users or services more permissions than they need. So I'm really encouraging you to not use stars. I've seen Helm charts or even manifests that were deployed manually, and the creator of these was recommending unnecessary permissions, even reading secrets from the whole cluster. So don't do that. The applications that are running there should have only those permissions that they need. And the stars have one other thing that might cause you trouble, because they are not specifically saying what the user can do. It can do basically anything if the star is used. And this can change the list of the, let's say, verbs or resources that can be controlled or that are covered by this star can change with the new version of Kubernetes. So upgrading the cluster might change the privileges you are giving to the users. Also, there are some things that you should be aware of. They are described in this article, RBAC Good Practices, and there might be somehow surprising, at least some of them. So one thing I will show you in the demo we will have today, that was very surprising to me. Regarding the RBAC and authorization in the cluster, overall, you should audit the changes, meaning you should see what is happening in the cluster and if there are any changes in the roles that are defined. So if you are using GitOps principles, you are deploying the applications and manifests automatically. That might be easier for you, but still there might be users that have access to the cluster, can do manual changes. So we should be aware of any changes that are happening besides the pipelines. And also, as I mentioned, with the star, there might be changes with the roles with new versions of Kubernetes. So we should be aware of what's happening even during upgrades. So that's basically it for the cluster layer. And I think we can get to the container layer. So we like containerization because it's encapsulating the application, it's making it separated, and you can start it on any system basically. But the encapsulation is done to that extent what the container runtime allows, and in Kubernetes, it's controlled by the manifest settings, and it's not about setting of the workload. Also, if the workload or the application, the container is vulnerable or have some vulnerabilities, you might give access to the attacker, and you might use the application for lateral movement and further finding other vulnerabilities in the network. So you should be aware of that, and you should take some measures to prevent these attack vectors, or at least minimize them. So let's go through some points again. There is a point of trusted registry. So we all use container images that are coming from third parties. They are stored in registries, but we should be more careful or on what images we use, and don't blatantly use any image that is available there, and especially not to use every new version that is coming out. You should take some measures and find out what's changed. I know it's not easy because there's many applications, many container images, it's changing, but it's really important to know what the changes are. So there are tools that might help you scan the registry. You should store the images in your private registry and have complete control of it. Of course, you can use a public registry, but it should be trusted at least to some extent. As for the vulnerabilities that can come into the images or might be present there, you can use image scanning. So that is something that is scanning vulnerabilities in the images, meaning the libraries that are there or the binaries. And if you combine this with admission controllers on Kubernetes, you can prevent running the vulnerable workload in the Kubernetes. I mean, before it enters the cluster. So that will be part of the demo as well. I will show you how you can scan the images with Runecast. Then there is point of workload settings. I will discuss this in more detail in the next slide. This will allow you to limit what privileges the container has on the host, basically. The point of workload isolation might not be useful for some of you, but maybe some of you are running some more security concerned workload or security sensitive, and for this purpose, you might want to isolate the workload from the other workload that's running in the cluster. So normally, the pods can run on any of the nodes. If you would like to isolate it, you can, for example, deploy the workload in a separate cluster. But there is also the possibility to set up the affinity, and you can ensure that the specific workload that is maybe more security sensitive is running on specific nodes. And the nodes can have different settings. They can have a different regime, different security options. And also there are runtime classes that can support that. You can leverage Selenium, Aparm or Seccomp, and use runtime classes to enforce these things that will help you to make the workload secure. So with these runtime classes, you can ensure that the container runtime, for example, is set in a way that it doesn't allow privileged containers at all, and the security constraint workload can run there. You can use centralized logging, and you should, because that will allow you to see the logs from all the containers in one place. It will help not only developers but also operators of the cluster see any changes that might be happening in the application, and if the centralized logging system will allow it or will offer this functionality, you can even set up some alerting that might let you know there are some changes when, for example, logging trends change and so on. Secrets management is a really huge topic, so I won't go into much details here, but let's mention at least something. Secrets in the Kubernetes are stored in database, and applications can use them for accessing external systems, or pod can use to communicate, for example, to database in the cluster. So that's why they're called secrets. They are stored in the database, as I said, but they are not encrypted. They are just base 64. Again, word, never mind. So base 64 covered, and basically they are in plaintext, so they can be easily read. So that's why you should encrypt the etcd database. It shouldn't be stored in plain, because the secrets can be then easily read from the hard disk if, for example, the hard disk is handed to third party, or if the third party has access to backups or similar things. Also, this is not the only thing that you can use to have secrets in the Kubernetes. Very popular is having secrets outside in external systems. So you can use systems like HashiCorp Vault or AWS Secrets Manager that will allow you to inject the secrets to the workload, not having it stored in Kubernetes API database permanently, but also this allows you to have the secrets with short validity, for example. So even if the secret leaks, the new start of the pod will fetch new secret that will be stored in the external system, and you can ensure with some tools that the external system is rotating the secrets more frequently. Besides these systems, there are, for example, approaches like Bitnami, Short Secrets, and Mozilla Secret Operations, which allow you to store the secrets directly in manifests via secure manner, which to me sounded a bit scary to have them stored in manifests and in repositories, but somehow it works, and it's also used in communities. So that's basically these points, and let's get back to workload settings, because that's a really important point. There are some settings that you can set on the workload that is running in Kubernetes. So let's say we are running a container with image tools, and if we don't set anything else, if the image is built in a way that it's running under root user, then the container will have root permissions, and you basically don't want to do that, because with root permissions, even if it's containerized workload, it can find out unnecessary information, and information about other workloads, can have more control on and more permissions on the host than needed. So that's why there are some settings you can set. There is a security context that can change the user that is used by the container image, and it can also ensure that it's not running as privileged user. It can ensure that it's not allowed to escalate the privileges, and this security context can be set on 2 levels. It's either in the pod directly on the specifications, or it can be set on the container level. So you should set the pod to the least privilege needed to run the application. And in the application, if the application needs something that cannot be done by these privileges, you can use, for example, init container that is preparing the environment for the application. So one example, for example, database can require some specific settings of file permissions, so we can have init container that will do that, and the database doesn't need to have these permissions. So you should limit the permissions of the container to the least available, so the application can run. You should also use a read-only file system. So, for example, if attacker gets into the container, is able to communicate in the via the network, so he's then not able to store the files and further do some actions. Also, you should limit capabilities, which is related to the privilege regime, and that will allow you to do some things on the host. For example, changing file permissions, stepping into the network communication, and so on. So this is something that we're limited. With the host port, that might be used with some containers to expose the container on each of the hosts in the cluster. For example, with ingest controllers, but this should be really limited to specific workloads, because once you enable that, the container is connected directly to the network stack of the host, and might be used for some attacks on the host. Also, there is the possibility to link some path from the host to the container. Again, it might be used. There are some use cases which use this and are useful. For example, logging agents that can read logs from the host directly. But again, the path should be limited, and also the containers that use this should be limited. And there is also the possibility of limit the host namespaces. So there is host IPC, host network, host PID, and they are limiting further actions the user, which is used in the container, can do on the host. So all these will basically allow you to limit what's happening, what the workload is allowed to do on the host, but by default they are not defined. So first, the container can run as root, if it's not specified in the image otherwise. And anyone who has access to the API, who can deploy the manifest there, can set the manifest in a way that the things can cause harm to the host. So you should be able somehow to limit this, and that's where policies come in. So there were pod security policies previously in Kubernetes. They were working, but they were complex to set up and not easy to implement. So they were replaced by pod security standards and pod security admission, and that's what I wanted to show you, because this is there by default. It's built in. It's enabled since 123, and you can easily use it to limit what can the workload do in the cluster. So pod security standards define 3 pod security standard levels: privileged, baseline, and restricted. And these levels basically say what the workload can do. Privileged obviously can do all the privileged operations that we discussed on the previous slide. Baseline is something that is limiting the workload. It cannot do most of the harmful stuff, but still there are some things that can be done. And restricted is the most restrictive, and is basically for the most restricted workloads. The levels are described in the documentation. I won't go into details, but it's easily accessible. So you have these 3 levels defined, and the pod security admission gives you 3 modes which you can these levels use. So you have mode of enforce. That means that any workload that will break the set level. So let's say I will say enforce and baseline, then I won't be able to start any privileged pod in the namespace, because this mode is set and will enforce. I didn't mention it's in the form of labels, so you just simply label the namespace, and that's it. It's working out of the box. Another mode is audit. That's basically transparent and it's not doing anything. Even the user doesn't know it's there, but it will log if the level is crossed, or if the workload wouldn't suffice the level, and it's logged in the Kubernetes audit log. And then there is a mode of warning that will again allow the workload to be started, but it will warn the operator in the API call, or in the return code. So this is something you can use. There is also a label that you can use to pin the version of the policy if the version changes with the new version of Kubernetes, for example, so you don't have any surprises. And this is something that can be easily used with 3 predefined levels. I will show you in the demo as well. But if it's not sufficient and you want to have more granular control, you can use other admission controllers. There are alternatives like Open Policy Agent Gatekeeper, Kyverno, Keyboarden, or JS Policy, which allow you to not only control what the workload can do, but basically anything in the cluster, like controlling labels, namespace names, whatever you can think of. The agents are able to be used to build complex policies, and not only to validate them, but you can also use a mutating webhook that will change the manifest on the fly and make sure that it adheres to your standards. Now let's switch to the demo. So what I have here is K3s cluster running on this laptop. It's just one node, obviously, version 126. And I've prepared 3 short demos. So one will show you one cache in the RBAC. The other demo in this, I will show you how you can use Runecast to scan vulnerabilities in the images. And in the third short demo, I will show you the pod security admission in action. It's there out of the box, and you can use it right away on your clusters. So let's first look on the first. This is already prepared in the cluster. What I have done is I created namespace demo RBAC. There is a secret, which is called credentials. There is also service account, which is called K3S user. It's just for these demo purposes. And this service account will be given rights to read anything in the namespace. So I've created role that has only list verbs. I have used star against the recommendations, but this is demo, right? And there's also role binding that binds this role and is giving this service account read-only access in this namespace or list permissions. So if I switch to the account, I can check. I have alias of kubectl, so I don't need to write it every time. So K means kubectl. I can easily check if I can get pods, for example. No, I'm not allowed to do that. I can also check if I can get secrets. No, that's expected because the user has only list rights. So now if I check if I can list the secrets, I can do that. Perfect. So as this user, I can get secrets that are in this namespace. And I can see there is a secret called credentials. So good, I have the list rights. If I want to get the secret now, I'm not allowed to do that because obviously I don't have the get verb to get the object. But there is this catch. If I list the objects, I can use output modifier, and if I use output to YAML, I'm not listing them, but I'm getting the content. So even if I have only list permissions, I'm able to get the content of the object. So with secrets, you should never give list permissions to anyone if he shouldn't read the secrets. So now I can easily get to the content of the secret and see what is said there. So again, a list is not a list. This was really surprising to me, and that is one of the catches of the RBAC. So you should be aware of how RBAC works and or how they work and what can be the things that can do to your cluster. So the second thing is image scanning. Here I have pre-configured the cluster so it can authenticate to Runecast. Yeah, maybe I should first show you that I'm running Runecast in this cluster. Okay, obviously not as this user. So there's Runecast running in the cluster or in the K3S instance. I have set it up the instance so it can authenticate to the Runecast service. And now I'm going to show you how we can use Runecast as admission controller to scan your images for vulnerabilities. So what I have here, I have two namespaces. One is called demo image scanning policy 1, and it will call Runecast and will ask for verifying the policy number 1. The second one is policy 2, and logically it will test for policy 2. Next, we have here validating webhook configuration. That's basically doing the stuff on the ground. So if you are creating some workload in the cluster or updating it, that is one of the rules that is set up here. And the resources are pods, daemons, and so on. then this webhook will be called. And so this is a rule where the webhook reacts. Also, it needs to be matched to this label. So that's basically the label of the namespace, which is above. And then if this matches, the service that is providing the validation webhook will be called. So let's check how it works. I have this namespace created, or both namespaces, and I have this validating webhook. And now if I'm trying to run workload, let's say Nginx, and if I will run it in the namespace demo image scanning policy 1, then this workload will be, I will send a call to API, to Kubernetes API. API will call the validating webhook, and Runecast will scan the image and return the information to the API and say if it's allowed or not. So if I'm scanning the image now, I should be able to find out if it's adhering to the policy or breaking it. And this workload is breaking the policy. This policy says that the workload cannot have any critical vulnerabilities. And Nginx container probably has some of them, so it was rejected. When I do the same in the second namespace, the image is again scanned, but the pod is created. So the pod is adhering to policy 2. The second policy I will show you in the Runecast application. So here I'm connecting to the Runecast instance that is running in the K3s on my laptop, and that was used as the validating webhook. Here, if I go to container security, I should see these two scans that were just right now 1 minute before done, and the first one was done with policy ID 1, and we can see that it's breaking this policy because there is critical workload. The second policy is policy 2, and that will prevent the workload to be run if there's critical or high severity vulnerability, but where fix is available. And this policy was not broke because we can see there are some critical and high level vulnerabilities, but there are no fixed libraries. So this image is adhering to this policy. So basically, this is how you can scan vulnerabilities in images. Runecast is one of the options you can use for that. And let's get back to the demo. I mean to the console demo. I will remove what I have created there. And there is this third demo I have prepared. And that's about the pod security admission. It's just two namespaces created with labels that are relating to the admission. So first namespace is demo PCA enforce. It's labeled with the enforce action, and it will enforce that all the containers that are run in this namespace need to the manifest cannot contain any settings that would break this restricted level of pod security standard. The second namespace is demo PSA warn. So there is again this restricted level, but the action will be warned. So again, I will apply this to the cluster. The namespaces are created. You can see them here. I can see the label. And now if I go run Nginx, again, my favorite image, and I will try to run it with privileged mode in the namespace demo PSA enforce. I'm not allowed to do that because there is this put security admission and this checking if the manifest is according to the policy, but this manifest is not like that, and it's breaking the privilege too. So easily I was able to block some kind of workload that doesn't adhere to the policy. With the warning, it looks similar. So now I'm creating the workload with privileged permissions in the namespace demo psi warn, and here I get warning that it's breaking the policy, but the pod is created. So as you can see, it's really easy. You just label the namespace, and you can use these predefined levels. Okay, so that was demo. I'm glad the demo gods were merciful today. And that's basically all for today's presentation. So let's sum it up. We went through a number of the points. You should be securing your API, minimize the attack vector. You should limit who can access the API from all the sites, so outside, inside of the cluster. You should know how RBAC work, and you should limit it as possible, so not give more permissions than needed. You can use policies and admission controllers to limit communication in the cluster, to limit what the pods can do in the cluster. With the admission controllers, there is a relation also with the image scanning. You can use admission webhooks that will prevent running vulnerable workload in the cluster. And specifically, you should audit, and that means audit everything that's happening in the cluster, not only in the pods, but also on the control plane. Check any changes that are happening there. There are tools that might be able to help you with that. Auditing RBAC, auditing cluster security awareness. You can use security benchmarks to help you with all the stuff that was discussed in this presentation. So yeah, that's what you should do. And there are other points that can help with security, like service mesh, eBPF, but that's out of scope of this presentation. I'm not sure if we have any questions. Okay, it was either lame or overwhelming. No questions there. So thank you for attending. If you like the webinar, you can check other webinars that we're recording and follow us on social networks to know about any new webinars that we are preparing. And you can try Runecast on your own. There are ways how to check the demo online or register for a trial.